Suppose this is a dipole, this point will take minus q. This is minus q charge, this is plus q charge. Usually what will be the distance between two charges in dipole? This distance is how much? For a dipole, 2a is the distance between two charges. So we will take a point P somewhere here. Point P is at this point, okay? And that point P is on the axial line. If you draw the axial line, this is the axial line. And that we are taking the point P. And that point P is at a distance from the center of the dipole. This point P is at a distance from the center of the dipole. R is the distance. Completed the diagram. Then write the introduction. Let P be a point. Let P be a point at a distance. P be a point at a distance R from the center of the dipole. R from the center of a dipole, constituted by plus q and minus q charges. Constituted by plus q and minus q charges, separated by a distance 2a. Here we have, in this dipole, we have equal and opposite charges, that is plus q and minus q, separated by a distance 2a. And this point P is at a distance r from the center of the dipole on the axial line. So here the discussion is about electric potential due to a dipole. The three cases are there. The first case is at a point on the axial line, means at the point P in this axial line. The second case will be at a point on the equatorial line, somewhere here, the equatorial line. Third case will be at a point, an arbitrary point, anywhere. You can take any point at any location, and what will be the electric potential because of this plus q minus q, means the dipole. So the first one is electric potential at the point P, which is on axial line at a distance r from the center of the dipole. And we have written in previous class, electric potential is always an algebraic sum. It is not a vector quantity, isn't it?
Yes, sir.
So I can write electric potential at P. The potential at P will be equal to, you can also write the equation. Electric potential at P is equal to potential due to plus q charge plus potential due to minus q charge, algebraic sum.
Sir, for this, for the potential at P, right, we are calculating, we are adding both potentials due to plus q and minus q. So for them both, plus q and minus q, do we take the magnitude or like the symbol as well, minus as well? Just the magnitude, right?
You have to take magnitude with the symbol also, sign also.
Symbol also?
Already we have written in the previous class, potential due to positive is positive. Positive charge will be positive potential, negative
yes, sir,
negative.
yes, sir.
So this plus will become minus when you add the value. When you substitute the value, this plus will become minus.
Okay, sir.
Okay.
Yes.
Then we know that electric potential at the point P due to plus q charge. Electric potential at the point due to plus q charge, if I write V due to plus q. Potential due to plus q. V due to plus q is equal to, what is the equation? Equation for potential. If it is placed in air or vacuum,
1 by 4 pi epsilon naught
into q by r.
1 by 4 pi epsilon. What is r here? Q by r. R is the
between
distance.
P and the center of dipole.
No. Normally in the equation for potential due to a point charge we derived in previous equation, that distance is distance of the point P from the particular charge.
Yes, sir.
So now we are considering only plus q charge. We are forgetting about minus q.
So from P to plus Q,
Yeah,
that
P
distance.
plus q, this distance is the r. So how much it is? Total length of the dipole is 2a. So this will be half is a. So this distance will be total r from the center minus this much, that is r minus a.
A.
Okay, is there any square in the denominator?
No.
No, sir.
No. Equation for electric field intensity at the point P due to plus Q charge is equal to V due to plus Q is equal to 1 by 4 pi epsilon naught Q divided by R minus A. Only R minus A, there is no square because it is potential. And no direction also, it is a scalar quantity, no direction also. The same way potential due to minus Q at the same point P. Now we'll forget about this plus Q, think that only minus Q is present. Then at the point P there will be a potential due to minus Q charge, and you remember potential due to negative charge will be negative potential. Potential due to positive is positive. So can you tell me the equation for electric potential at the point P because of this minus Q charge?
1 by 4 pi epsilon naught Q by R plus A.
R plus A.
Minus 1 by 4 pi epsilon naught.
Minus.
Okay, the minus sign because it is negative charge. Potential due to negative is negative. So minus 1 by 4 pi epsilon naught. Minus 1 by 4 pi epsilon naught. Q divided by distance. Distance of the point P from minus Q charge is this total R plus this A, half of the dipole axis. So R plus A will come denominator. Therefore the total potential, if V is the potential at the point P, the net potential at the point P can be obtained by adding potential due to plus Q charge plus potential due to minus Q charge. Means that by adding these two, while adding the plus become minus here because this potential of minus Q charge is negative. So next line you write down the net potential at the point P due to the dipole. The net potential at the point P due to the dipole, comma V equal to adding both potential due to plus Q charge, this one, and potential due to minus Q charge, this one. While adding, this plus become minus due to the negative potential of minus Q charge. 1 by 4 pi epsilon naught Q by R minus A, plus become minus here, 1 by 4 pi epsilon naught Q divided by R plus A. Here we can take Q by 4 pi epsilon naught common factor outside. Inside bracket what is remaining?
1 by R.
R minus A and 1 by R plus A. 1 by R minus A minus 1 by R plus A. Then we can take LCM at the denominator, LCM as for R plus A into R minus A plus B into A minus B form. So the net potential V can be written as V is equal to Q by 4 pi epsilon naught inside bracket. I'm taking the denominator A plus B into A minus B. R plus A into R minus A as the LCM. R plus A into R minus A. So the numerator I should cross multiply. Here R plus A, then minus in bracket R minus A. That is potential B is equal to Q by 4 pi epsilon naught, and denominator we can write A plus B into A minus B.
A square
A square minus B square. So R square minus A square. R square minus A square. And numerator, this bracket when we open, it become R
R will get
plus A minus R, minus into minus here, this minus into minus become plus A. So both R will get cancelled. A plus A become 2A. Potential V is equal to Q by 4 pi epsilon naught. The numerator become 2A, A plus A 2A, plus R minus R is cancelled. 2A divided by square minus A square. Square minus A square. Put a bracket here also. What is Q into 2A?
Dipole.
Yeah. Q into 2A is dipole moment P. Dipole moment P.
Is equal to P by.
So 1 by 4 pi epsilon naught divided into P by R square minus A square. V is equal to electric field due to a dipole is given by 1 by 4 pi epsilon naught. Q into 2A we are substituting as dipole moment P, the magnitude of dipole moment, divided by R square minus A square. This is the equation for electric potential at a point on the axial line of a dipole. Electric potential at a point at a distance r from the center of the dipole on the axial line. Now if it is an ideal dipole, what is an ideal dipole? Ideal dipole means like a molecule of HCl. Ideal dipole means the dipole axis length is very very small, like a molecule of HCl. You remember in molecule of HCl, if you take a molecule of HCl, hydrogen and chlorine. Chlorine is more electronegative, isn't it?
Yes.
Since chlorine is more electronegative, the two electrons of covalent bond will be more shifted towards chlorine. Chlorine will attract the shared electron more towards it. As a result, chlorine side become a delta negative charge and the hydrogen side become a delta positive charge. These are equal and opposite charges separated by a small distance, that is the bond length of HCl. It is nearly some 2.73 degree Armstrong. Very small value. And this molecule we can consider as an ideal dipole. So the condition for ideal dipole is the dipole axis length, half of the dipole axis length. Half of the dipole axis length means A. Total length we are taking 2A. So if A is very less than distance r, distance from the center of the dipole is r, and such dipoles are considered as ideal dipole. So if it is an ideal dipole, A is very very small compared to the distance r, means if you take this half of the distance of the dipole axis length, that is very less negligible compared to the distance of the point P from the center of the dipole, that is r is very large and this A is very less. So we can neglect A here. Then what will happen? If you neglect A in this equation, half of the length of the dipole axis, then the
P by
equation
R.
becomes V equal to what? For an ideal
1 by
dipole, we
4
can
pi
write the
R
equation V is equal to 1 by 4 pi epsilon naught P by
P by
R.
R.
Square.
Okay. 1 by 4 pi epsilon naught P divided by R square. This is for ideal dipole. So you have to write a sentence here. For an ideal dipole, A very less than R, so it can be neglected. A can be A square will become still smaller, isn't it? A is very small, means A square will be still smaller. If you square a fraction, it becomes again smaller. So A square can be neglected. Means finally the equation become V equal to 1 by 4 pi epsilon naught P by R square. This then